Hi. This is Zihua Lu. Today I am glad to introduce our work with Hiroki Sakuma, VSRD, Instance-Aware Volumetric Silhouette Rendering for Weakly Supervised 3D Object Detection. Existing monocular 3D object estimators heavily rely on supervised learning using abundant 3D labels manually annotated on LiDAR point clouds. This annotation cost is extremely high, posing a significant barrier to deploying 3D object detectors into autonomous driving systems. To address this issue, we treat the 3D detection task as an SDF-based surface reconstruction challenge. We break down a car's surface into two components, a box SDF representing the basic 3D bounding box, and a residual SDF that captures the deviations between the car's irregular surface and the box. This approach transforms the 3D detection problem into a more manageable SDF-based surface reconstruction task. In our paper, we present VSRD, a two-stage weakly supervised 3D object framework. The first stage utilizes multi-view images with our new auto-labeling framework to generate optimized 3D bounding boxes. The second stage uses these boxes as ground truth to train monocular 3D detectors. In the multi-view 3D auto-labeling phase, we model each car as an instance SDF using an instance SDF learner and generate rendered masks through an instance-aware volumetric silhouette rendering module. The optimization of 3D bounding boxes relies on the loss between these rendered masks and the ground truth. This page shows more details of the learning of the instance SDF. We represent the surface of each instance as an SDF and decompose it into the SDF of a 3D bounding box and the residual distance field, RDF, which is learned via a hypernetwork. The composed instance SDF is used to render the silhouette of the instance through our proposed instance-aware volumetric silhouette rendering. During this process, we can optimize the 3D bounding boxes. Additionally, we propose instance-aware volumetric silhouette rendering, which averages instance labels at each point along a ray based on their signed distances. This data is integrated using an SDF-based volume rendering formula, improving the renderer's understanding of interinstance geometric relationships. This page shows how the SDF is optimized from a random box to the surface of cars. The 3D bounding boxes optimized by the proposed auto-labeling are not reliable for dynamic, occluded, or truncated objects. Therefore, we propose a confidence assignment method based on the multi-view projection loss. It helps us to train more reliable 3D detectors. Our proposed VSRD is a plug-in module that can be used for any monocular 3D object detectors in a weakly supervised manner. Compared with other existing methods, our proposed VSRD has better performance. Visualization results also show that our method can estimate more accurate 3D bounding boxes compared with other methods. Besides, our proposed VSRD can also be performed in a semi-supervised manner by using the KITTI 360 pre-trained model's weight and fine-tuning a subset of the KITTI 3D dataset. The performance of the detector fine-tuned on only 50% of the labeled data significantly outperforms that trained on the whole data from scratch, highlighting the broad applicability of our method. This slide shows the inference video using weakly supervised mono-DTR using VSRD on the KITTI 360 dataset. Our method can generate satisfactory 3D bounding boxes with using LiDAR sensors both in the training and inference phase. For more details, please refer to our project page. Thank you.